of change. Okay? Does anybody know another word for rate of change? Yes. What is it? Read aloud. Slope. Okay? So if we talk about another word for average rate of change, it's just going to be slope. Okay, so slope and rate of change or average rate of change, they happen to be the same thing. So when we looked at slope, okay, we can use it on the graph and just do rise over run, or we can use our slope formula, which is m equals y2 minus y1 over x2 minus x1. We're going to use both, okay? So if you look at the points that you have on your graph, go ahead and do rise over run on those. I think our rise is 4. Do you agree with 4? And our run is 5. Now, taking a look at this line, should our slope be positive or negative? It should be negative because it's going down from left to right. So for rise over run, we would get negative 4 over 5. Okay, and if you did not grasp slope when we did it before, okay, because some of you were still trying stack and subtract and it did not work and we did not do well in your quiz, today is a good day to kind of restart on slope, okay, because I'm going to go through slope again today because we're going to use it a lot, okay. So the first thing on slope is you need to have 2 points, okay. So let's go ahead and write down our points from our graph. -2, 3, and 3, -1. We're going to use those 2 points to find slope. Okay, I always label mine x1, y1, x2, y2. I always label those guys. Okay, and then you simply just plug your numbers into the formula right here. Okay, so we'll have y2 minus y1. y2 is -1 minus y1, which is 3. And then x2 is 3 minus x1 is -2. Now, in the denominator, we have double negatives. What does that mean? Yeah, it should be a positive. So here we get -4, and this is a 5 because those turn positive. Okay, so if you look at our rise over run versus the slope that we calculated, they're the same, and they should be. Okay, you won't always be able to count. So rise over run is not always feasible. You do have to be able to use the formula as well. Okay, sometimes it's nice because you get a graph and you can count. Sometimes you're going to have to use that formula. Okay. I want you to notice on this graph that our line is completely straight. The reason that we talk about not just rate of change and slope, but now we're going to add this new concept of average rate of change is because we won't always have straight lines. And we're going to see that here today. Okay. So if we look, okay, for a line, if we have a straight line, what do we say that the slope is? If it's always the same, there's a specific word. Constant. Yes, it's a constant slope. So there's a constant slope if something is a straight line. If it's not a straight line, your slopes will be all over the place. Okay, they will not be the same. All right, so example 2. We have a family and they're going on a trip to the beach. Okay, they leave at 6 a.m., which is right down here at the bottom left-hand corner. Okay, and they end at 2 p.m. So the issue is our time. Take a look at this time down here. We go from 6 to 8 to 10 to 12 to 2. Mathematically, that's going to cause a problem. But we can rewrite 2 p.m. in a different way. How can we rewrite it? 14. So we're going to use military time kind of here. Okay? So we're going to change that to 14. Just mathematically, we're going to use 14. Part A says the graph shows a change in speed by 8 a.m. What is the average rate of change? What's another word for average rate of change? Slope. Okay, so what is the slope in miles per hour between 6 and 8? Okay, so if you look between 6 and 8, we can just do rise over run. What's our rise? Starts at 0 and goes to 150. Okay, because here we can't just count boxes. Why can't we just count boxes? Because if we count the boxes, that would be 1, 2, 3, 4, 5, 6. That would be 6, right? not going to work. But how much does it go up? Look at your y-axis. 150. Okay? It goes up 150. Okay? And it goes over how many? From 6 o'clock to 8 o'clock. 2 hours. Okay? So you really have to keep your scale in mind there. Okay, so our rise over run is 150 over 2. Which is 75. Okay, and that's 75 miles per hour. Is that a valid speed? 75 miles per hour? Kind of fast, right? So if you think about what kind of road they're on, what would you assume? A highway, right? They're going 75 miles per hour, they're on a highway. Hopefully they're not going to like downtown Delaware 75. Probably gonna get picked up. Right?
I think we got pulled over at it was between 10 to 12. We stopped.
Yeah. So right, their speeds are changing. Yeah. So we're gonna find 12 to 2. So we'll see what that one is. Okay. So in part B, we're gonna do 12 to 2. Now in this one, we can do rise over run. Okay. So if I go from 300 to 350, that's a rise of 50. Rise of 50. Okay. What's my run? If I go from 12 to 2. Think about 12 to 14. 2. Okay, that's 2 hours. So that's going to be 50 over 2, which is 25 miles per hour. Okay, what kind of road do you think they would be on there? Maybe they're like in a town, right, or something like that. Probably not a back road, because back roads people probably usually go like 50 or something like that. But through a town, that would make a little bit of sense. Because think about like they're getting to a beach. Okay, so they're going through some type of trafficy area. All right, C, what is the average rate of change in miles per hour between 11 and 12? So if you look from 11 to 12, okay, so that would be, oh golly, right here to here, this part right here. We don't even have to calculate anything. What's the slope of a horizontal line? 0. Think about slope, dude. Okay, this is 0 fun. Okay, so the slope is 0. What do you think is occurring during this time? What's happening from 11 to 12? They stopped. Why would they stop? Traffic, to eat, gas, lunch. Okay, think about it. Okay, I love all of those answers, but let's narrow it down. If it's during the day and you've been in a car, okay, and it's 11 o'clock to 12 o'clock, what typically happens during that time? Lunch, people eat, okay? Could they also be getting gas? Probably, because it's about halfway through their trip, or a little bit, about 3/4. Okay, so they may be getting gas, but they may also be eating. Maybe traffic? Probably not. Okay, but let's just narrow it down here. Would they only stop to get gas? They could, but why is that not feasible for this problem? It's an hour, right? It's 11 to 12. It's an hour long. It's not going to take an hour to get gas, hopefully. Okay? So eating lunch is the more feasible option there. Does that make sense? Okay. So probably eating lunch. Okay, and you could put also getting gas. Okay, but they wouldn't only be getting gas. It might be something that's added on there. Okay, let's keep moving. Part D, what was the average rate of change in miles per hour for the entire trip? Okay, can we do rise over run for that? What do you think? What do you think? The entire trip, like we're going from this point to this point. Can we do rise over run? Yeah, we can. Okay, or we can calculate it. What do you want to do? Do you want to try to do rise over run, or do you want to use points? Points? Let's do points since we did rise over run on the other one. So if we did points, okay, what if we have x is 6 to start, what's the y value there? How fast are they going at hour 6? 0, right? 0 miles per hour. Okay, we're going to use 14 mathematically here. Okay, so 14, they're at what for y? 350. Okay, so we're going to use our slope formula. 350 minus 0 over 14 minus 6. So that's 350 over 8. And I think that's 43.75. If anybody wants to check it, they're calculating. Yes. Okay, good. So they are going about 43.75 miles per hour average. It's not saying that they're constantly going 43.75. It's saying that on average. So they might be going faster than that, they might be going slower than that, which we found, right? We found that at some point they were going 75 miles per hour, at another point they were going 25 miles per hour. So this is just average, if we were to calculate that. Here's another way to think about it. If I was to connect point A and point B, so where they started to where they finished, what would be the slope of my straight line? What would be the slope? No? What would be the slope of my straight line? Yeah, what do you think? The average, 43.75. Because if you think about it, we took those 2 points and we calculated the slope. Okay, so the slope of, if I just connected those with a straight line, would be 43.75. Now, it's not realistic, right? Like, think of, like, if we're going to drive from here to Columbus, I can't just drive through a school building and I can't drive it through the grass, right? So that's why this kind of stuff has to happen first thing, right? I can't just go a certain speed and kind of cut through buildings, okay? Part E, between what hours do you think the family is traveling the fastest? Where do you think they're traveling the fastest? Shout them out. 6 to 8. Anybody have another thought? What do you think, Max? 10 to 11. 10 to 11? Any others?
You said 11.
11 to 12?
No, I was joking.
Oh. Okay, so let's just calculate. Actually, did we already find from 6 to 8? What was it? Was it 75? I think it was 75. So then we haven't found 10 to 11 yet. So 10 to 11 would be 1 hour, and it jumps from 225 to 300, which is 75. Is 75 over 1 75? Yeah. Okay, so they're actually both the same. The average rate of change there is 75 miles per hour. All right, how did you tell? Like, why did you guess those 2 specific areas? Yes, the line was steeper there. Okay. Did the family drive the same speed through the entire trip?
Yes.
No. Right? We just figured that out. No, they did not. Okay. They had all different speeds. Okay. Now, sometimes we're given x values. We have to use y values and actually calculate the slope. Okay. So I'm going to kind of show you how to go about doing that. So here we're given 2 x values. Okay? And you have to find the y values. So you're given x values to find the y values. So when x is -6, what's y here? What's y? 1. What about when x is -2? What's y? -3. Okay, now we're going to calculate slope. All right, so we would have -3 minus 1 over -2 plus 6. We end up with a double negative there. -4 over 4. You should get a slope of -1 for that one. Okay, I'm going to have you do B, C, and D on your own. So you're writing down the 2 points and then calculating slope. Okay, so go ahead and do B, C, and D on your own right now. some slopes when you want to check those. Okay, are there any questions or issues on finding the average rate of change using slope formula with these kind of problems? Anything I can go through with you? Okay, let's keep moving. We're almost done, okay? Here's an OST type of question. We took it from the OST test, okay? It's a very popular question because it happens a lot. Like, these kind of questions happen a lot. So, if we have this and we have a function, okay, you won't be given this part. You won't be given the table and the graph. You'll just have a question that looks like this. And they're asking you, okay, over the value of y, is it increasing from 6 to 7? Well, based on knowing that this is your equation, can you tell that? Like, can you tell that based on just looking at an equation? No. What do we have to have? We have to have a visual, right, which is a graph. So we're going to use Desmos. So go ahead and get out a way to use Desmos, whether it's your phone or computer, whatever you want to use. Okay, and we're going to type this into Desmos. Now, if you look at the specific problem here, we're going to rewrite this. Okay? Instead of y of t, Desmos doesn't like that. So we're going to use f of x, and we're going to write it like this. So we're going to change everything to x. So you're going to have f of x equals negative x squared plus 14x minus 40. So that's how you're going to put it into Desmos. If you have a question getting that to come up, let me know. Do you remember how to add a table? Yeah. How do we do that? Plus sign. Okay? Choose table. Do you remember what we did to the x? Yeah, get rid of the 1 that's on that x. Okay? And then y1 is not going to be y1. What do we replace that with? Remember? We're basically putting in our function right there. F of x. We're going to type in f of x there. Okay, now look at your table. What does your table start with on your notes? Starts with 4. Okay, so that's what you're going to put into Desmos. And once you hit 4 and then 5, it should let you just hit enter, and you can go all the way to 10, and you can fill in that table. Okay, I know it's hard to see up here. My table reads 4 to 10 on the left, and on the right it's 0, 5, 8, 9, and then 8, 5, 0. Okay, once you get that, go ahead and record that on your notes. Fill in the table and graph it with those points. going to kind of discuss the question here. So once we have that drawn, now we visually can see what's going on. Okay, so in this first part, it says the value of y increases from 6 to 7. So when x is going from 6 to 7, is y increasing? Is it going up? Yes. Okay, so that is a yes. We can go ahead and check that one off. What about the second one? The value of y increases from 7 to 8. So look, from 7 to 8, it's going down. That means that it's what? Decreasing. So that one's not true. We're not going to check the second one. The third one says the average rate of change. What's another word for average rate of change? The slope, right? The slope from 6 to 8 is 0. Can we tell that based on looking at the graph? What do you think? Here's what we need to do. Okay? We need to write our points. So at 6, the y value is 8, and at 8, the y value is 8. Okay? We're going to quickly just do slopes. You can just kind of plug and chug here. So we'll have 8 minus 8 on top. 8 minus 6 on the bottom. What happens when you have 0 in the numerator? The slope is... Nope. 0. Undefined is when it's in the denominator. Okay? So when it's on top, it's a slope of 0. So this happens to be true. That happens to be true. Okay? Here's another way that you could have looked at it. I wanted you to work it out. Okay? But you could say, okay, at 6, here's that point. At 8, here's that point. Well, if I connect those, what's the slope? 0. Okay, so you could have visually looked at it, but I wanted you to practice your points. So you can do it both ways. All right, the value of y is constant from 6 to 8. What does constant mean? What type of graph do we have if something is constant? Straight line. So from 6 to 8, okay, now don't ignore this, what I just drew. I can't erase that. Let me do this. Okay, ignore this part, because that's not really on our graph. Okay, so from 6 to 8 on our graph, this part right here, is that a straight line? No. Okay, so it's not constant. Last one. The average rate of change from 6 to 7 is the same from 7 to 8. So here's what I want you to look at. From 6 to 8, would you say that the slope is positive or negative? What about from 7 to 8? Can they be the same? No. Okay, so we wouldn't check that box. All right, go ahead and work on the practice. Okay, the answers are at the back on the bottom. Okay, you can check yourself as you go. We have a test. Test A is going to be on Friday. Okay, so it's going to be over function notation, which is what your quiz that I gave you back today is over. Okay, and it's also going to be on this kind of stuff. Okay, domain and range and this. You can retake your quiz that you took today on Friday, okay, during test time, okay? Or you can take it on Monday when we have the review section, okay? So you have some time to retake that if you want to retake that quiz, okay? I'm going to let you work and I'll walk around and help you out. Did you get it?